Hey guys, welcome to part 1 of my course on how to turn a single photo into a 3D virtual reality application. Imagine being able to explore your favorite movie scene or a place you've always dreamed of in a fully immersive way. So this is what we're going to talk about in this course. Today, however, we'll focus on a tool called fSpy, which allows you to calibrate the camera. You know, its location, rotation, field of view, and stuff like that. Then we'll do some draft modeling in Blender and create a paper-like model. I mean, I call this a paper-like model because this isn't the final scene, but rather kind of stencil with proper dimensions, proportion, and placement. Now, those of you who've already seen fSpy are probably like, hey, what are you talking about? There are so many fSpy tutorials out there. Why do you even bother? Well, the problem with most of those tutorials is they don't explain the whole workflow. They usually focus on the vanishing points and ignore the other fSpy parameters. And although it is tempting to believe that this simple approach is enough, the truth is sooner or later you'll get into trouble unless you understand all these settings and know how to determine the proper values for them. So I'm gonna show you how to do it using this reference image. It is called the Orion apartment, and I found this picture on Behance. It was designed by Michael Argvest's studio. Okay, so let's get started. I'm gonna drop our image onto fSpy canvas now, and the first thing you do here is to find the vanishing points. That's exactly what these red and green lines are for. They come in pairs, which we aim to align with the image by placing them along mutually parallel lines. Of course, what I mean by parallel lines is parallel in 3D space, not in the image, since after the perspective projection, they are not parallel anymore. They converge at some point called the vanishing point. It's essential to understand, though, that some axes might not have their vanishing point. It all depends on the image and its perspective. So if you draw the lines and they don't converge because they are parallel, not only in 3D space but still in the image, you'll get this little error message. And this is where some people make this first mistake. They try to cheat fSpy. I've even seen this in a few tutorials by tweaking the line until the error message disappears. Remember not to do it this way because it means you're creating a vanishing point where one doesn't exist. So my piece of advice is to analyze your image even before you launch fSpy and draw the lines along the coordinate axes X, Y, and Z, because then you can see whether they converge at some point or if they are parallel. Just take a look at our image. It is now clearly visible that there are no vanishing points for X nor Z, and there's only one along Y axis. Okay, so let's get back to fSpy and begin from the scratch, but this time we're gonna do this properly. Remember, the very first thing you do here is specifying how many vanishing points your image has. So let me set this to 1 and select Y as the vanishing point axis. There is one thing that is a little bit misleading here because fSpy asks me to select the second vanishing point axis despite I only have one. We'll get into that shortly, but you can select whatever you want here, X or Z. Okay, so we can start the alignment now, and there are a couple of things to remember if you care about accuracy. First of all, it's good to press Shift because it opens up this zoom circle and also turns on the precision mode, which slows down your mouse. You also shouldn't draw the lines too short because tiny mouse movements in such a case will make huge difference. So the longer lines you draw, the better accuracy you get. And for the very same reason, I wouldn't recommend drawing the other line too close to the first one because the vanishing point becomes overreactive. I usually draw the lines at the extremes of the image, as long as I have the reference over there, of course. Okay, let's get back to the second axis now. This time we don't have another pair of lines, there's just a single one, and obviously we need to align this with the image as well. So I can draw it here, and it has to go along the second axis I chose. I told you it's not important if it's X or Z, but you have to be consistent now. And as you see, the thing I'm doing right now is rotating my coordinate system along the first axis. This is the purpose of this line, to rotate the coordinate system. Okay, we are almost done. It's still flipped though, so let me change X to minus X, and yeah, it's okay. We can validate our perspective now by dragging this origin and matching it against various areas of the image. As you can see, apparently we have some issues with the Z-axis. It doesn't align well with the underlying picture, but kind of bends towards the middle of the image. This problem is very common with images that have less than 3 vanishing points. Generally speaking, axes without vanishing points are troublesome. Not always, but quite often. fSpy simply doesn't have sufficient information to do its job in such cases. Some people mistakenly try to fix this by readjusting the lines they've drawn, but this approach is just another common mistake, leading them nowhere. The root cause of this problem lies in a badly placed principal point, which is the essential part of the perspective, because this is the point onto which the perspective center is projected. Unfortunately, this point isn't something you can easily spot just by looking at the picture. It's not as simple as with the vanishing point, where you draw the lines and see where they meet. Luckily, there are other techniques that can be used to find it, but before I show you how to do it, let me explain what this principal point is. So we have a camera and the image plane, this flat two-dimensional plane onto which the scene is projected, as visible here in the camera perspective view. I'm going to add a line from the camera center perpendicular to the image plane. This line is called the principal axis, and the point where it meets the image plane is called the principal point. Now, imagine you add a tiny sticker at this position so that it's visible in our rendered image. And because it's a sticker, it won't change its location even if I move or rotate my camera. It's like a laser pointer telling us what the camera is currently looking at. Sometimes it is also called the image center, and by default, it is indeed located at the center. Nonetheless, it doesn't have to be there. Otherwise, I wouldn't be talking about it, because fSpy could simply divide the image resolution by 2 and it would know its coordinates, right? But the thing is, the final image can be manipulated. Someone can crop it, and in such a case, our sticker won't be at the center anymore. And of course, in real life, there will be no sticker at all, so you'll get a picture and will have to find this place yourself without knowing if the image has been manipulated or not. And to make things harder, there isn't a single approach to do this, but rather a couple of different strategies. And the one you choose depends on the number of vanishing points your image has. So to show you all of them, I'll use these 3 pictures. We already know that the Orion apartment has 1 vanishing point, this other picture has 3, and the pool has only 2, which, quite surprisingly, is the most difficult configuration. But we're going to go through all of them, so let's just start with that buildings which have 3 vanishing points. Playing with such images is the most effortless, because fSpy can figure out everything automatically. All we have to do is to draw and align 3 pairs of lines. Okay, but where is the 3rd pair of line? I can only see 2. Well, it's not visible by default. You have to activate it. And you would probably imagine that you do this by setting 3 as the number of vanishing points in this drop-down over here, but quite surprisingly, it only lets you choose between 1 and 2. So what you do instead is you go to the principal point dropdown and select the last entry called from 3rd vanishing point. And then you get this 3rd pair of lines. Keep in mind though that this option isn't available if the number of vanishing points is set to 1. In such a case, you'll only have the image midpoint and manual modes. So remember, if you don't see this item, First set 2 vanishing points and then go back here and select the proper value. Alright, let's start dragging. I'll speed this up a little bit. When we finish, an orange circle will appear on the screen, and this is the principal point that's been found. And we don't have to do anything else. If we validate the perspective, we'll see that all 3 axes align perfectly. This was easy, but let's open our next image. So where are the vanishing points? These parallel lines at the edges of the pool converge, and so do those along the other axis. Okay, and the vertical lines are mutually parallel. It's particularly noticeable near the edges of the image because they are perfectly parallel on both sides. So let's start as usual by aligning the existing pairs of lines. Okay, what do we do then? Well, chances are that the image hasn't been manipulated. It is the desired situation, because in such a case, the principal point will be at the center. And because this is also the default value in fSpy, we don't have to do anything else. All 3 axes will have this nice alignment. This is the simple case, of course. Unfortunately, our z-axis doesn't align well. Apparently, this image has been cropped, so we have to switch to manual mode and locate the principal point ourselves. I know it's tempting to use this automated discovery mode from third vanishing point, but although this option is visible, don't choose it. This is not going to work this time because we don't have the third vanishing point. So we have to stick to manual and do something. The rule of thumb is grab the principal point, this little orange dot, and drag it along the direction of the parallel lines, those without the vanishing point. So if the parallel lines in our image are vertical, we must drag the principal point vertically, up or down. This will rotate our z-axis and will let us align it with the image. Usually, as we drag the orange dot vertically, we also unintentionally change its horizontal position. It's because fSpy doesn't have this option to constrain the movement to one axis, and it's hard to drag your mouse that precisely. And we can check it over here by reading the current position. I usually prefer relative units instead of pixels because 0.5 means the middle, no matter what resolution your image has. And yeah, as anticipated, the x coordinate is not 0.5, so it's advisable to fix this now. I can grab the point and move it horizontally using the precision mode. I have to be careful though not to change its vertical position, what usually happens. Okay, so far so good, but I also have some bad news. Although all 3 axes align well, it doesn't mean that we found the right position of the principal point. Frankly, we have absolutely no idea what its horizontal position is, and it's also very difficult to find it. Unlike with the z-axis, moving this point left or right will not change the angles of the coordinate axes, so we can only rely on the proportion between x and y vectors. Believe me, finding this position accurately is a daunting experience. A lot of guessing, trying, verifying, and a lot of round trips between fSpy and Blender. I'd spend another half an hour to do this, so I'm not going to talk about this specific case right now. Let's just keep our fingers crossed that this image was only cropped on its top or bottom and not on its left or right side. Because if it hasn't changed its width, then the horizontal placement of the principal point will be in the middle. Okay, so let's head to our last example, the Orion apartment. And this is the strategy that you will use for all those one-point perspective images. It's actually pretty straightforward. You just have to remember that for such images, the principal point overlaps the vanishing point. the only vanishing point that the image has. So basically, all you have to do is to switch to manual mode and drag the principal point on top of the vanishing point. That's it. Anyways, there's this nasty little thing in fSpy that the vanishing point disappears as soon as you activate the precision mode. You don't see those lines in the magnifying glass. So it's a little hard to be accurate, and to overcome this problem, I usually drag the focal length slider all the way down, or even type something ridiculously small like 2 to increase the distortion, because this will emphasize even the tiniest offset from the right position, and it will also force me to be very precise. And now I can set the principal point by dragging this orange dot until the axes are properly aligned. Okay guys, now you know how to set the principal point for all types of images. Although this is not the end of work that needs to be done in fSpy, let's go to Blender for a second to see what it looks like there. You'll need the fSpy add-on for Blender to import the fSpy project file, and when you do this, a new camera is added to the scene and it has this background image already set. Now, to show you what the current problem is, I'm going to add a circle here. And as you see, it has this weird proportion. It is horribly stretched, and this is because our field of view is way too large, 167 degrees. Now, where did Blender get this value from? As you can imagine, it was set by fSpy, so if we go back there and look around, we'll see that there is such a thing as field of view, and it reads 167 degrees, but this is a read-only field. As a matter of fact, it's calculated from two other fields, the sensor size and focal length. So, although we cannot control this directly, we'll do this by changing the focal length. And the relation between these two is the lower focal length you provide, the higher field of view you get. Sensor dimensions can be left with their default values. I mean, they are helpful in one case. When you somehow know these values, both sensor size and focal length. I don't know, maybe from the author of the image or maybe from the metadata. If you know them, simply type them in and you're done. Otherwise, use the following process. First, guess what the value might be. Second, match a known shape against the image. And third, keep doing this until it looks good. Yeah, there's going to be a lot of eyeballing in this stage, and it's best to use one of the basic shapes for this, like a circle, a rectangle, maybe a hexagon, whatever works for you. We have to locate one of those shapes in the image. So let's have a look. I guess the base of this pillar is a circle. This lamp has also a circular shape, and that tabletop seems to be a hexagon. Okay, we have some references. Now, how do we match them? Well, fSpy only provides a simple 3D guide as a reference, so my recommendation now is don't do it in fSpy. Use Blender instead because it gives you total flexibility and you can match any shape you wish. It's worth noting that unlike fSpy, Blender allows you to edit both field of view and the focal length. Whichever value you update, the other is recalculated. You can switch between these units in camera properties. There are those two options, field of view and millimeters, which stands for the focal length. And as you see, it has this value of 2 millimeters that I've already typed in fSpy. So I'm going to increase this to some arbitrary value, let's say 7. And now I have to retry what I already did, which is matching my circle against the pillar base. It looks better, but still not good enough, so we'll need to check some other values. Remember that if you prefer to use field of view instead of focal length, just change the unit. By the way, our field of view has been recalculated and it's lower now, 137 degrees instead of 167. Anyways, the only way to find the right value is to keep trying. And although I could do this here with the pillar, it is slightly better to match the shape further from the principal point. And it's because the distortion near the principal point might not be that evident. Usually it's best to do this near the edges, so let's use the lamp instead. Because the circle is still stretched too much, I need to lower the field of view. I'm going to switch the unit to focal length though. It doesn't matter at all, but it's just my personal preference. Okay, so let's type a larger value. By the way, every time you change it, you need to reposition the reference shape. Don't worry, it's normal. 10 is still not enough, so let me try 15 and... well, now it looks like it's stretched in the other direction, so I think I've overshooted it. Let's try to decrease the value, and now it looks pretty nice. Okay, I'm gonna double check it by adding another shape here. This time I will use a hexagon. And to add a hexagon in Blender, you can select the circle and set the number of vertices to 6. So let's scale this down and... oh yeah, there's one very important thing you need to remember. When you scale your reference shape, do this uniformly because you don't want to change its proportion. Okay? Right, so let's rotate this along z-axis by 30 degrees and yeah, this looks very well, which means we got the proper value now. So we are almost at the finish line, but because this whole thing is supposed to work in virtual reality, there's still this little problem. Take a look at this. I added the circle at the bottom of the pillar, and I'm going to extrude this all the way up to the ceiling. And look at the dimensions. The pillar has 7 centimeters. It is less than 3 inches. Now, I don't know how large this room is, but I'll bet you dollars to donuts that it's not that small. So let's finish our job in fSpy and match the proper dimensions. Of course, before we measure anything, we have to set the focal length to the proper value. And now we know it's 14, so let me type this here. By the way, you're not limited to integers. You can use fractions if you wish, but since our value was 14, I'll get back to it. Now we need to find something with known size, but if you have no idea what dimensions particular items have, there is this great website called dimensions.com. You can type whatever you want here, and they have this enormous database with dimensions and also some sketches which can be used as reference images. I think it's invaluable for 3D modelers. Okay, but I think I should find something with kitchen in its name. Maybe these kitchen cabinets. Let's see what their standard size is, or maybe even check a dishwasher, because I believe that a segment in the kitchen has the width of a dishwasher. Alright, so it's 60.3 centimeters. Okay, so there are those two things you need to do in order to set the dimensions in fSpy. First of all, you have to anchor this origin to something you can measure, and then you set the reference distance. And although you can put this origin anywhere on the image, I highly recommend doing this somewhere on the floor. This point will be the center of our Blender scene and the only reference when we start modeling. And if you mess it up, all these measurements that we're going to take now will be useless. I mean, although starting from a different point is still feasible, it's going to be more error prone. Anyways, I'm gonna measure this cabinet over here, so let me change the reference distance from the default value to the appropriate axis. In our case, this is Y. So I got this additional ruler with 2 handles, and now I can grab the origin and move it here. As I said, it's better to have it on the floor level, so let me put this a little lower. And now I can grab the handles of my ruler to match the reference distance. And because we know that it has 60 centimeters, let's just type it in here. fSpy has this little bug. If you type anything, you can't press tab because the value will disappear. You have to confirm everything by pressing enter. And yeah, that's it. We've finished our work in fSpy. Remember though, we are halfway through. There are still several mistakes that you can make in Blender, so don't forget to watch the rest of this video. And if you like it, leave a comment and hit the subscribe button. Okay, let's make a 3D sketch now. This is what it's gonna look like. At this stage, it's enough to use the basic building blocks and simple shapes because all we need is to quickly adjust the sizes and proportions. We're not going to use any advanced modeling techniques today. Simple extrusions and transformations will suffice. We'll focus on the challenges you'll face and the mistakes to avoid. So, one of the biggest mistakes people make is forgetting about the depth. And to show you what I mean, let me model this pillar over here. I'm going to add a circle, align it with the image, and yeah, it seems good. But the problem is I have absolutely no idea how far from my camera the object is. So I might as well have another pillar significantly smaller, move it closer to the camera and align it with the first one. And because this is a two-dimensional image, it gives us this false impression that both pillars have equal size and are located next to each other. But if we switch to the 3D view and look at the scene from a different perspective, it becomes clear that none of these are true. So, like it or not, it's impossible to determine all three coordinates from a flat image. You need to know at least one to get the other two. This is why we need the origin. It's the center of the scene, and because it's attached to some objects, we know that these objects have one of their coordinates set to 0. In our case, these are the floor and this side of the island. And because we know one of their coordinates, we can safely align their meshes with the image and get the correct results. So I can add a plane, make sure it has its x coordinate set to 0, and now align its edges with the image. And then add another plane for the floor, ensuring its z position is 0, and also do the same thing. Okay, and now we have more reference points, not just the origin. We know the position of this edge, so we can model the countertop. We also know where these edges are, so we can model the windows. By the way, I told you earlier that I usually put the origin on the floor. This is very convenient because it lets me model anything that starts at my floor level, in particular this pillar. I just have to remember not to start from the top because I don't know its height, but from the floor, which has its Z position set to 0. So I'm going to add a circle on the floor and align it with the pillar base. All right, now there's this crucial thing I did. I pressed G followed by Shift Z to constrain my movement along the floor plane. It's because pressing G and freely moving the mouse changes all three coordinates. But because we're looking at the image from the same position all the time, it is hardly noticeable. And that's why I'm hammering the point home that in this part of the process, almost every grab operation should be constrained. So you press G followed by X, Y, or Z, or to select the whole plane, G followed by Shift X, Shift Y, or Shift Z. It's very easy to forget about it, especially when you make slight adjustments, so let it better become your habit. Alright, but let's finish our pillar by adding a face and extruding it all the way up. Good. Now I got the proper height of the pillar and at the same time the height of the apartment, so I can duplicate the floor, press Z to move it vertically, and then snap it to the top of the pillar. And from now, we can model the new objects also from the ceiling level. By the way, you might have noticed that I haven't used this button to toggle snapping. Neither have I pressed Shift-Tab to activate it. And it's because Blender has this neat option. When you drag anything, you can press and hold the Control key and it temporarily activates the snapping mode. I use this frequently because it's less clicking, and sometimes I realize I need to use snapping when I've already started dragging, so without this little shortcut, I would have to stop it, turn the snapping on, and then grab my object again. But with this control key, I can use it anytime, and it's really convenient. Okay, there are a couple of other tricks I'd like to share with you, and I'll need this tabletop for this, so let's model it. I can't do this directly because none of its coordinates are known at the moment, so I gotta start from the bottom, just like with the pillar, align it precisely. Okay, and now grab it up along Z, add a face, and extrude it because it also has some depth. Okay, now that I know where the tabletop is, I can model next objects from here, like this book. And here's the other trick. As you know, Blender adds new objects at the cursor position. So I can click here and then drag the cursor with my mouse. But the best thing is that the control snapping I've just presented works in this mode as well. So if you have the snapping target set to face, you can put your cursor onto any surface right away. And although from this view it's not that apparent, it will be well pronounced in the 3D view, so let me split the viewport. And by the way, I usually split my screen this way. It lets me simultaneously align the meshes with the image and still look at them from different angles when I need it. Okay, but if I want to add this book over here, I can drag the cursor, hit the control key, and my new object appears where it should. So let's scale this down, fix the position a little bit, and extrude it, and we're done. But I'm going to share another secret. I'm too lazy to manually switch between these tools, so I never use this button to move the cursor. There's a better way to do it. At any time, you can press Shift and then hold the right mouse button, and out of sudden, you're dragging the cursor. And while dragging this cursor, you can press the control key and you can snap it to the surface. And this is absolutely brilliant because the whole operation doesn't take more than moving your mouse, so you can rapidly add new objects at the desired locations. But there's even more you can do to optimize your workflow. Because sometimes you want to snap the cursor to a face, sometimes to a vertex. So if you don't want to waste your time on switching between these snapping targets, you can actually set both of them. I'm not sure if you're aware of this, but the snapping target window allows to select multiple items with Shift. So vertex plus face is my default configuration. And this is an amazingly powerful time saver. You have to be aware though that the order of the keys you press is vital. You start with Shift, right mouse button, and only when you start dragging, the control key. Because if you press Control followed by the right mouse button, it will activate this lasso selection tool. Anyways, let's move to the other side of this apartment and this dining chair to talk about another problem you may face. Sometimes, especially when you deal with irregular shapes, you may have troubles with proper alignment. Let's assume you want to align this edge with the leg. But again, because this is a two-dimensional picture, I have no idea if I should move it along the X or Y axis, because both give fairly good results. So here's the trick. If there are more identical objects in the image, like these 6 chairs, you can leverage the fact that each gives you a slightly different perspective. So you create a link duplicate of the object by pressing Alt-D instead of Shift-D, and now all your modifications of the mesh are applied to both objects. Actually, they share the same mesh. You can still move and rotate the objects separately to align the copy with the other chair. And now the problem we had isn't relevant anymore because you have more references to look at. So whatever you do has to be aligned nicely with all the references. You can also switch between the objects and use their local orientations to constrain movement. It really helps. If you're interested in how I modeled the whole scene, you can watch the rest of this video. Otherwise, see you in part 2, where I'm going to cover the modeling techniques and create the final 3D model. Thanks a lot for listening. I hope these advice were helpful, and let me know if you have any questions or believe that something can be done better. And again, don't forget to subscribe. Good luck. Take care.